Hello and good morning dear students. So today is 5th of August, right? And we were doing exercise 8.18 and the question that we are doing is question number 5 part 1. Okay, so in question number 5 part 1, integration 0 to pi by 2 log tan x. So 0 to pi by 2. So I hope you can guess which property we have to use. Yes, we have to use property number 4 out here. Okay, so we'll use property number 4. We'll keep this as equation 1, and now we'll be using property 4. So pause the video. I'll show the steps now. Alright, so let us keep the first given question as equation number 1. We'll use property 4. So using property 4, x will be upper limit minus x. That is pi by 2 minus x. So that is cot x. That becomes equation number 2. Now adding equation 1 and equation number 2, we'll be getting 2i, and you know in the right hand side how to add. So log tan x plus log cot x means log tan x into cot x, and we know that tan x and cot x are reciprocal, so it gets cancelled out. So therefore I will be getting here something like this: 2i is equals to 0 to pi by 2 log, see, tan is 1 by cot, so it gets cancelled out, so log 1 dx. And I know that log 1 is, what is the value for log 1? Log 1 is 0, so into dx, so 0 into dx is 0, so 2i is equals to 0, so hence I itself is equals to 0. So in this way we will be doing equation number 5 part 1. Number 5 part 2, you'll do it yourself. Okay? Pause the video, note it down. Alright, let's move on to now question number 16 part 1. Again here also we have to use property 4. The question is 0 to pi sine square x cos cube x dx. Keep it as equation number 1. And if I use property 4, I'll be getting 0 to pi sine square pi minus x cos cube pi minus x. Now, sine square pi minus x. So is it sine 180 minus theta? So sine 180 minus theta lies in which quadrant? So this is 90. This is 0, 90, 180. So 180 minus theta lies in the second quadrant, and in second quadrant sign is positive, and this is even multiple, so sign remains as sign. So I is equals to 0 to pi by 2 sine square x remains as sine square x. Okay, and now into cos 180 minus x. So first of all, in the second quadrant cos is negative, and even multiple cos remains as cos, so hence it will be minus cos cube x dx. Alright, and this minus some sign comes here, so 0 to pi, it will be sine square x into cos cube x dx. Alright, so I is equals to, from equation number 1, if you see this is your I itself, isn't it? So bring this side, I plus I will be 2i is equals to 0, and this will give you again I again is equals to 0. Okay? I also equals to 0. So this is question number 16 part 1. We move to 16 part 2. Please pause the video, note it down. Alright, let's move ahead with question number 16 part 2. Alright, so 16 part 2, the question is 0 to 2 pi cos to the power 5x dx. So 0 to 2 pi cos to the power 5x dx. So whenever we see 0 to 2 pi, whenever I see 0 to 2 pi, I've told you we have to use property number 6. And we have not done any sum based on property number 6, right? So this is the sum that we are using property 6. Quickly let's go to property 6. 0 to 2a fx dx is equals to twice 0 to a fx dx and 0. This is possible when f of upper limit minus x is fx, and this is possible when f of upper limit minus x is minus fx. Okay, this is property number 6. Now come back out here. It is 0 to 2 pi. So what is the value for a out here? Pi. Okay, and this is my fx. Now I know I have to use property 6. Anyhow, I have to use property number 6, and if I have to use property number 6, I have to check this too. Either this or this. I'm getting this. If I'm getting this, I have to use this is equals to this, and if I'm getting this, then I have to use this is equals to this straight away. Okay, now here fx is cos to the power 5x. What is my upper limit? 2 pi. So what will I check? F of upper limit minus x. So fx is this. So I'll be checking f of upper limit minus x. So wherever it is x, you put upper limit minus x. So cos to the power 5, upper limit minus x. Now we'll be checking whether I'm getting fx back or whether I'm getting minus fx. If I'm getting fx, I'll have to use the first one. If I am getting minus fx, straight away the answer is 0. Okay? Now, cos 2 pi minus x. So where is my 2 pi? 2 pi means this, 360 degree. So 2 pi minus x means in the fourth quadrant. So all sine, tan, cos. So cos is positive in the fourth quadrant and 2 pi is even multiple. So cos remains as cos. So hence I will be getting cos to the power 5x, isn't it? So f of 2 pi minus x, and getting back, if you see, this is the value for fx, which is equals to fx. So hence what we are getting, f 2 pi minus x is equals to fx. So therefore, this integral will be the first one, isn't it? So 0 to 2a will be now twice 0 to a. So this will be twice 0 to a means pi cos to the power 5x dx. I hope you are clear with this. Please pause the video till here and note it down. Alright, I hope everyone is clear till here. Now from here, which means I am getting this, isn't it? Twice 0 to pi cos to the power 5x dx. Now keep it as equation number 1. Now 0 to pi, so which property use? Again property 4. So by property 4, 2 remains 2, 0 to pi remains 0 to pi, but wherever it is x, it will be upper limit minus x, a minus x. Now sine 180 minus x, please make the quadrants all sine, tan, cos, and this is 180. So sine 180 minus x means in the second quadrant cos is negative and even multiple, so cos remains cos, so minus sign comes out here, so twice of this means I, so hence it is minus I. Again bring this side, 2i equals to 0, hence I equals to 0 is the answer. So please pause the video and note it down. So alright, let us start with question number 12, part 1. So in question number 12, part 1, the interval is 0 to 5 fx dx, but the value for fx is given in terms of modulus. And now we know that whenever it's given in terms of modulus of algebraic functions like this, x plus 2, x minus 3, we always use property number 2. Remember property number 2 yesterday we have done, that we can break the whole interval as 2 or 3 intervals, isn't it? So now, how to break the intervals? Let us see. So, okay, before that, I have to choose a number in between 0 to 5, where somehow any of this will be 0. Okay, so see how this will be 0 if I put x equals to minus 2, but x equals to minus 2 does not lie in this range, so I cannot take. But x equals to 3, if I put x equals to 3, this will be 0, isn't it? So hence I can break this interval, capital I suppose, this interval as 0 to 3 fx dx, and then 3 to 5 fx dx. Okay? I hope this is clear to you all. Now, 0 to 3, what is the value for fx? We'll find. And 3 to 5, what is the value for fx? We'll find and we'll put out here. Okay, so to do that, 0 less than x less than equals to 3. Okay, 0 less than equals to x less than equals to 3 means within 0 to 3 we are now finding the value for fx. Now, come back out here. For this interval, fx is equals to, okay, now let's go term by term. Okay, if you put x equals to 0, x equals to 1, x equals to 2, or even x equals to 3, which means all the values of within this range, the value for modulus of x plus 2 will be positive. So hence mod of x plus 2 will be x plus 2. Okay, and now if I put x, okay, for mod x plus x minus 3 now, if I put x equals to 0, negative. Put x equals to 0, it will be negative, isn't it? But the function of modulus is to make positive. Put x equals to 1, negative, x equals to 2, negative, so hence it will be minus of x minus 3. I hope we are clear with this. Okay, because modulus has two values, one is positive, other one is negative. If somehow we are getting negative out here, then put a minus sign out here, so that negative into negative will be positive. Okay, so x cancel out, and 2 minus and minus plus, so this will be 5. So value for fx in the range 0 to 3 will be 5. Okay, now for which interval? 3 to 5. 3 less than equals to x less than equals to 5, fx is equals to, in the same way we will check for mod x plus 2 and mod x minus 3. So for mod x plus 2, you put x equals to 3 or any number in between 3 and 5. 3 if you put positive, 4 if you put positive, 5 also you put positive, so hence it will be how much? X plus 2, right? Now I don't know whether it will be plus or minus sign, so I am not writing out here. Before we check, you put x equals to 3 or any number in between 0 to 5, sorry 3 to 5. 3, 0, it is positive, 4, positive, 5, positive, so hence it will be positive. So I hope you are clear why negative out here and why positive out here, okay? Because it is positive. And here what I was getting, if I put x equals to 0, I was getting minus 3. If I put x equals to 1, minus 2, minus 1. So then I need to have minus sign out here, okay? So therefore this will give you 2x minus 1, isn't it? So these are the value for fx in these ranges, okay? So therefore you put out here 0 to 3, what will be the value for fx in this range? 5 dx, and 3 to 5, the value for fx is 2x minus 1 dx. Now quickly I want you all to simplify this and get the answer, okay? So when you simplify it, after integration you'll be getting this, put the upper limit minus lower limit, and you'll be getting the answer as 29. So pause the video and note it down. We move to the next sum. Alright, in the same way, question number 12 part 2 is there. Integration 1 to 3, and the function is mod x minus 1 plus mod x minus 2 plus mod x minus 3. Okay, now the range given to us is 1 to 3, right? The range given to us is 1 to 3. So choose any number in between 1 to 3 where any of this will be 0. See, I cannot choose x equals to 1 and I cannot choose x equals to 3. The middle number has to be in between 1 and 3. So the only number that in between 1 to 3 which gives one of them is 0 is 2 at x equals to 2. Because see, I cannot put x equals to 1 according to property 2. The middle number, if I am breaking the interval, the number has to be in between 1 to 3, isn't it? So I cannot put x equals to 1, x equals to 3, and x equals to 2 only. So hence, if I break this, I will break in this interval as 1 to 2 fx dx, and then 2 to 3 fx dx. So the value of 1 to 3, the value for fx in the range 1 to 3 will find out. Similarly, the value for fx in the range 2 to 3 also we'll have to find out here. Okay, so for 1x less than 2, fx will be, okay, so if I put x equals to 1 or if I put x equals to 2, I'll be getting 0 or positive, so hence the value will be positive, no problem. If I put x equals to 1, now you can clearly see here I'll be getting negative. If I put x equals to 1, I'm not talking about 2, if I put x equals to 1, so 1 minus 2 is minus 1, isn't it? But modulus, the function is to make positive, so the value for this will be minus of x minus 2. Similarly, if I put x equals to 1 out here, or even if I put x equals to 2, both the values will be negative, so hence the value for modulus will be minus of x minus 3. So therefore, if I simplify it, you will be getting x minus 1 minus x plus 2, right? And then minus x plus 3, isn't it? So plus x minus x gets cancelled out. I'll be getting 5 minus 1 is 4, 4 minus x. So this is the value for fx in the range 1 to 2. Please pause the video, note it down. And similarly, for this interval 2 to 3, for 2 to 3, for 2 to 3, if I put x equals to 2 or 3, positive, so x minus 1. If I put 2 to 3, again this is positive, so x minus 2. And if I put 2, there will be negative, so hence minus of x minus 3. So I hope now you are clear with this. So therefore x plus x and minus x. So 2x minus x is x, minus 1 minus 2 is minus 3, and plus 3. So I think it gets cancelled out, so only value will be fx. So these are the values of fx in the given interval. Pause the video, note it down. Alright, so when I put the values, it's 1 to 2 fx, 4 minus x, 2 to 3 fx, x, and now you know what to do, integrate it, put the upper limit minus lower limit, the whole calculation I've shown out here, this step, and when you take the LCM and simplify, the answer will be 5. Okay, so please pause the video, note it down. Alright, dear students, so this is the last question for today, question number 12, part 3, 0 to 3 fx dx. This is the function given to you. Now choose any number between 0 to 3 where any of this modulus will be 0. So exactly at 2 points you'll get at x equals to 1 and at x equals to 2. So hence I can break the interval as 0 to 1, 1 to 2, 2 to 3, fx, 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 and the values I found out here. Okay, I've shown out here. Please take the respective values and then integrate this. Okay, so pause the video, note it down, and I'll give you the assignments now. Alright, the assignments for today will be question number 5 part 2 and question number 12 part 3. So please complete all the sums in today's class and then submit by tomorrow. Thank you.